Now we're going to talk about numbering systems. And the numbering system that we're really familiar with is a base 10 numbering system, right? So if I have 2, 1, 3, 5, 3, so this number, notice that it has 2 3s in it, but they're very different values. This 3 is the number 3, right? Where this 3 is 300. So why is this one worth 300 and this one only worth 3? It has to do with the place that they're in. And this is really how our number system works. The place where the number is makes a difference. So 2 things. We have a certain number of digits to work with. We're working in base 10. So the digits allowed in base 10 are 0 to 9. Notice how this keeps popping up, that we go to 0 to 1 less. Right? We do that when we're doing index of an array. We do that when we're doing remainders. This pops up over and over again, and the number of digits is the same thing. So base 10 is 0 to 10 minus 1. So that's the digits that are allowed in base 10. So we can use those different digits, and then their value depends on what place they're in. So let's go ahead and pull this number apart. So I'm just going to put some tabs in here to pull this number apart so we can look at what each place value is. Now this is something that you are very familiar with just because you've been working with it for a long time. And I'm going to start from the right because this is really tells us we can build the place values this way. So we're using base 10. So 10 is the base, and then the very first place value is that the base raised to 0. So 10 raised to 0 is 1. That's the ones place. The next one will be the base raised to 1. In this case, it's 10 raised to 1, which is 10. So that's the tens place. The next one is the base raised to 2. And notice how we're just increasing that exponent each time, and we're keeping the base the same. So this is the 100s place, because 10 squared is 100. The next is 10 raised to the 3. So that's the thousands place. And then 10 raised to the 4 is the 10,000ths place. So each time we're always using the base, and then we're changing the exponent for each place value. Okay? And if we keep going, it just increases by 1 every time. So we get that one, and then we have the 100,000. So that place value becomes significant. And to expand this number, so the expansion of this number is to identify the value of each one and to write it out. And we do this in our head, so we don't write it out very often. But it's really 2 times and 10 to the 4th, the place value, right? So 2 times the place value. And then we do plus 1 times 10 to the 3rd. Again, times the place value. And so this is the expansion of how we write this number out. And then 3 times 10 to the 2nd power, 10 to 2. And here we see where this value is worth 300 because it's 3 times 10 squared. And then we get 5 times 10 to the 1 power, right, which is 10, and plus 10 to the 0, or 3 times 10 to the 0 power. And here's how we see the difference between the value of this 3 and the first 3. Because they're multiplied by a different place value. So you see their difference. So this is the expansion of that number. This is all stuff you already know. This is the base 10 numbers that we're really familiar with. But now what we want to talk about is, what about if we use a different base? And it turns out we don't have to use 10 for our base. That's our common one. But there are times when using a different base becomes valuable. Especially in computer science, base 2 is significant because that's how computers store data, is that they work with base 2. And let's talk about base 2. So if we're going to do base 2, there are some things that we need to know. The digits can be, remember, it's 0 to the base minus 1. So it's 2 minus 1. So the digits for base 2 are 0 to 1. Another common base that we work with is base 16. We call that hexadecimal because that's much more human readable than base 2, and it's a really easy conversion from base 2 to base 16. So base 16, the digits are allowed, right, are 0 to 1 less than 15, which are 1 less than 16, which is 15. And so base 16, we have this different set of digits. Now notice in this case, it takes two digits to make that up. So we can't do that in a number. Each digit only gets one space in the number. So the way that this works is the digits 0 through 9 work the way we normally see them. Then 10 is A, and 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So the way we write the digits, the digit 10 we write with an A, the digit 14 we write with an E. So that's how we get the digits 0 to 15 to fit in individual spaces. So this is the concept of the different digits that are allowed. And then we also, the place values change. So for base 2, the place values are going to be 2 to the 0, right? 2 to the 0 is the one going to be on the far right. That's still the ones place because everything to the 0 is 1. So instead of 10 to the 0, it's going to be 2 to the 0. The next place value is going to be 2 to the 1, which is the 2's place. The next one is going to be 2 to the 2, which is the 4's place. The next one is 2 to the 3rd, which is the 8's place. And this is how it works for any base, that you can compute the number of the digits that are allowed in the number and the place values. So base 16 works exactly the same way. Tab in, and the first one is 16 raised to the 0, which is 1. Always start with the ones place on the right. That's important. 16 raised to the first. And this is how you get place values.